Sir, hello. Hello.
సార్ ఓకే మాట్లాడండి
Okay, sir.
సార్ వినపడుతుంది ఓకే రైట్ మోడ్ కూడా ఓకే
So, good afternoon.
Good afternoon, sir.
So now we will discuss it about here one of the new chapter, chemical bond. Chemical bond is a fundamental chapter in chemistry. It is one of the most important chapter for examination point of view. So what we have learned from chemical bond? So in this chapter, we have learned about here types of bond. So causes to the formation of chemical bond. Next one, formation of ionic bond and the factors affecting of ionic bond and characteristic properties of ionic bond. Next one, here covalent bond. So covalent bond, so in this one, the characteristic properties, formation of covalent bond. So these are discussed in this one. Then theories of bonding. Theories of bonding is nothing but, so here especially VBT. Next one here, valence shell electron pair theory, hybridization concept, and molecular orbital theory. So molecular orbital theory is one of the most important theory. So in this unit. So moreover here, some important points for this unit, dipole moment. So percentage of ionic characters, Fason's rules. So these are very, very important thing for chemical bond. Okay. So what is chemical bond? So what is chemical bond? Try. line. Here, a combination of atoms with attraction forces. So here, attraction forces. So here, a combination of atoms with attraction forces. Here, simply, so A is an atom. So it is combined with, so one of the atom is B to get AB. This is a molecule. So A and B both are different or similar atoms. They are combined with some attractive forces. These attractive forces is represented as a chemical bond. These two chemical species is attract with some attraction forces. Presence of these attraction forces to get a new compound that is called as AB. So the AB is different from A and B. The properties of AB is different from A and B. So this is represented as what is about here, chemical bond. So chemical bond is nothing but the attraction forces present between atoms. So what type of attraction forces present in a molecules? So generally, chemical bond, this is a chemical bond. Mainly classified into two types. So here it is classified into two types. One is intermolecular. Sorry, I will write here. This is interatomic forces. So here, these are intermolecular forces. So now, the chemical bond is mainly classified into two types. One is interatomic forces and another one is intermolecular forces. So interatomic forces, intermolecular forces. The bond present, the attraction forces present between atoms, so that is called as interatomic forces. The force of attraction present between molecules, they are called as intermolecular forces. Interatomic forces is mainly, one is here ionic bond or covalent bond. Ionic bond, covalent bond. Here, coordinate covalent bond. Coordinate covalent bond. And one more is that is called as metallic bond. So here interatomic forces, there are different types. One is ionic bond, covalent bond, coordinate covalent bond, and metallic bond. Intermolecular forces, there are two types. One is van der Waals forces. Van der Waals forces. And another one is hydrogen bond. So hydrogen bond and van der Waals forces, they are intermolecular forces, because here these attractions present between molecules. So again, van der Waals forces are classified into different types. So what are they here? They are ion dipole interaction, dipole-dipole interaction, ion-induced dipole interaction, London forces. London forces. So these are classified into 4 types. So here van der Waals forces, they are ion-ion interaction, ion dipole interaction, dipole-dipole interaction, induced dipole interaction, so London forces. So these are van der Waals attraction forces. The attraction forces present between, what is about here, sir? Molecules. Hydrogen bond, it is also classified into 2 types. So what is? One is intermolecular hydrogen bond, and another one is intramolecular hydrogen bond. So intermolecular hydrogen bond, intramolecular hydrogen bond. So the hydrogen bond present between, so highly electronegative atom and hydrogen atom. But here intramolecular hydrogen bond, the hydrogen bond present between 2 groups within the molecule. The hydrogen bond is present within the molecule, intramolecular hydrogen bond. The hydrogen bond formation between molecules, that is called as intermolecular hydrogen bond. ఇప్పుడు మనం బెస్ట్ ఎగ్జాంపుల్ తీసుకుంటాం అనుకో, వాటర్ తీసుకున్నాం అనుకోండి. వాటర్, అమోనియా, హైడ్రోజన్ ఫ్లోరైడ్, para, nitro, phenol. So these are nothing but intermolecular hydrogen bond. Intramolecular hydrogen bond, so they are especially salicylaldehyde. Salicylaldehyde intramolecular hydrogen bond. Orthochlorophenol, intramolecular hydrogen bond. Orthonitrophenol, intramolecular hydrogen bond. So this is regarding about here hydrogen bonds. Next one here. So here the intermolecular attraction forces. So here they are very, very weak forces. Weak forces. Weak forces. Their energies are 2 to 40 kilojoule per mole. 2 to 40 kilojoule per mole. Especially the hydrogen bond is 10 to 40 kilojoule per mole. No, hydrogen bond is 10 to 40 kilojoule per mole. So here van der Waals forces is a very, very weak forces. Their energies are very, very less. So here this is totally intermolecular forces 2 to 40 kilojoule per mole గా మనం దీన్ని ట్రీట్ చేయడం జరుగుతుంది అన్నమాట. బట్ interatomic forces, so the interatomic forces are, they are strong forces. They are strong forces. Its energy 200 to 400 kilojoule per mole. Their energies are very, very high. The energies of interatomic forces are 200 to 400 kilojoule per mole. So this is regarding about a brief description for types of chemical bond. So chemical bond is interatomic forces, intermolecular forces. If it is possible, Nana, ఒకవేళ మీరు స్క్రీన్ షాట్ తీసుకుంటే తీసుకోండి. ఓకే, రైట్. నెక్స్ట్, here cause of chemical bond. Causes of chemical bond. What is the causes of chemical bond? Here, so generally we will take here atoms and here molecules. Atoms and the molecules. Here, atoms are unstable. Molecules are, what is about here? Stable. So here, the potential energy or energy, high potential energy for atoms. They are low potential energy. Next one here. To possess inert gas electronic configuration. Inert gas electronic configuration. Here, so here they have non-inert gases. And it means ఏంటంటే సాధారణంగా it cannot equal to inert gas. Sorry. Oh, sorry. So here, unstable electronic configuration. So here, stable electronic configuration. It means that is called as noble gas. It means octet configuration. Octet configuration. So these are different regarding about here atoms and molecules. So generally, the unstable atoms is converted into stable to the formation of chemical bond. So here, when the conversion of atoms to molecules, the potential energies are decreases. The potential energies are decreases. Next one here, unstable electronic configuration to stable electronic configuration. by gaining or loss of electrons. Nana, atoms, why they are converted into molecules? So here, unstable atoms are converted into stable molecules. High potential energies are converted into low potential energies. So here, unstable electrons configuration to stable electronic configuration. So that is a cause of chemical bond. So the bond present between atoms in a molecule. So because here to get a stable. So this is expressed in what is about here, some terms, some graphical methods. I can express it here. This is a here potential energy is increases. This is here R. So R is nothing but distance between atoms, So we will take here, what is about here? The distance between atoms. So we are taking here two atoms like here, A and here one more A. So the potential energy, this place is 0. Okay. Here we can observe that the graph can show as like this. So what is meant here? So this is for R is equal at infinity distance. These atoms are at infinity distance. Their potential energies are 0. Their potential energies are 0 whenever it is infinity. So they are coming close to each other. It means the distance between two atoms are decreases. Their potential energies are decreases. Their potential energies are decreases. So whenever it is reaches, the potential energy is minimum. So the potential energy is minimum. It is indicated by, this is so this is a potential energy minimum. So the distance between, this is for R naught. So whenever they are coming to close to each other at certain distance to form a chemical bond. Whenever they are coming too close, their potential energies are increases. So here, this place is nothing but the distance between two atoms, that is called as bond length between atoms. Suppose here the hydrogen molecule. So in that hydrogen molecule, so the bond distance is 0.74 angstroms. These two hydrogen atoms are coming to close at 0.74 angstroms. A covalent bond is formed because here their potential energies are minimum. A less potential energy. So whenever it is less potential energy to form a chemical bond. నానా ఇక్కడ నేను చెప్పేటటువంటి అంశం ఏంటంటే రెండు ఆటమ్స్ ఉన్నాయి నాన్న, They are, suppose here this is hydrogen atom, this is hydrogen atom. They are at infinity distance. Their potential energies are 0. We are coming to close. It means to attract, to increase attractions between hydrogen atoms. So what happened here? So when the attractions are increases, their potential energies are decreased. So it reaches low potential energy. So it means a bond formed between atoms. This is a low potential energy, corresponds to bond distance between atoms. So that is represented as bond length. So this is called as, what is about here? Bond length. So bond length between atoms. Suppose hydrogen molecule తీసుకున్నాం అనుకోండి, the bond length is 0.74 angstroms. ఇంకా దగ్గరకు వచ్చింది అనుకోండి, అప్పుడు ఏమవుతుంది? పొటెన్షియల్ ఎనర్జీస్ ఏమవుతున్నాయి? ఇంక్రీజ్ కావడం జరుగుతుంది అనమాట. అంటే ఇట్ మీన్స్ ఎందుకు పొటెన్షియల్ ఎనర్జీస్ ఇంక్రీజ్ అవుతున్నాయి అనే దానికి నేను ఇక్కడ మీకు ఒక ఇంపార్టెంట్ థింగ్ చెప్తాను. యు సీ హియర్. So when we are taking here, this is a nucleus. Here, this is one of the nucleus. Next one here. So here, this is electrons are revolved around the nucleus. Okay. What is about here? This is A, this is for B. Okay. So in that one, here, the Na, it means a nucleus, and here, Nb, nucleus. So the nucleus, next one, Ea and Eb. అంటే ఇందులో ఉండే న్యూక్లియస్, ఇందులో ఉండే న్యూక్లియస్, ఇక్కడ ఉన్నటువంటి ఎలక్ట్రాన్, దిస్ ఈస్ ఏ వన్ ఆఫ్ ది ఎలక్ట్రాన్, హియర్ ఆల్సో ఎలక్ట్రాన్, బోత్ ఆర్ నెగటివ్ చార్జెస్. సో వాట్ హ్యాపెన్ హియర్? సో సేమ్ టైప్ ఆఫ్ స్పీసీస్, దే ఆర్ taking repulsions. But here, the nucleus of A is electron of B. And here, nucleus of B is electron of A. What type of forces are present? So they are, what is about here? Attraction forces. Nana, same type of species. Ante nucleus madhya untundi, positive kabatti repulsions untai. So electron kabatti negative charges kabatti veeti madhya untai repulsions untai. But ఇందులో ఉండేటటువంటి న్యూక్లియస్, దే ఆర్ అట్రాక్ట్ విత్ దిస్ ఎలక్ట్రాన్. దిస్ న్యూక్లియస్ ఈజ్ అట్రాక్ట్ విత్ దిస్ ఎలక్ట్రాన్. వెన్ ది అట్రాక్షన్స్ ఆఫ్ opposite electrons with opposite nucleus, so here to form a chemical bond. So whenever to coming to close, so there are repulsions are indicated. అంటే ఇక్కడ నేను ఎందుకు ఇది చెప్పానంటే, ఇక్కడ సర్టెన్ స్టేజ్ వరకు మాత్రమే అట్రాక్షన్స్ ఉంటాయి. సో వెనెవర్ క్లోజ్ టు ఈచ్ అదర్, సో దే కెన్ టేకింగ్ యాజ్ రిపల్షన్స్. అంటే అప్పుడు ఏమవుతుంటాయి? రిపల్షన్స్ స్టార్ట్ కావడం జరుగుతుంది అనమాట. సో దిస్ ఈస్ రిగార్డింగ్ అబౌట్ హియర్ వాట్ ఈస్ సార్ కాజెస్ ఆఫ్ కెమికల్ బాండ్. Next one here, in that chemical bond. So what we have learned? So we have learned about here from ionic bond. So in that ionic bond, so formation of ionic bond, formation, lattice energy. Next one here, percentage of ionic character. Next one here, properties. Properties. So these are discussed in this unit. Next one here, covalent bond. Covalent bond here, formation of covalent bond here. So Fazan's, sorry. Fazan's rules. These are very, very important for Fazan's rules. Next one here, dipole moment. It is also very, very important. Dipole moment. So these are discussed in this one. Next one here, theories of covalent bond. So in that one, VBT. Next one here, Vesper theory and hybridization concept. So next one here, most important thing is MOT. So these are very, very important things. Next one here, another one is coordinate covalent bond. Coordinate covalent bond. So here, metallic bond, metallic bond. So in that one, so free electron theory. Next one here, that is three types of theories are there: free electron theory, VBT theory, and molecular orbital theory. So now one more is hydrogen bonding. So these are discussed in this unit. So before going to that, so previous slide. So what is about here, sir? The atoms to get a low ionization potential and to get a stable octet configuration. So when the getting of stable octet configuration, it is loose or gaining of electrons from valence shell to get a stable electronic configuration or nearest stable electronic configuration. So that is nothing but formation of bonding. So in this one, it is a very, very important for this unit. మనం ఇందులో నేర్చుకోవాల్సినటువంటి అంశాలు అంటే స్ట్రెచ్ చేయవలసినటువంటి అంశాలు లాటిస్ ఎనర్జీ, పర్సెంటేజ్ ఆఫ్ అయానిక్ క్యారెక్టర్ క్యాల్కులేషన్ అడుగుతుంటాడండి ప్రాబ్లమ్స్లలో. నెక్స్ట్ వన్ ఏంటంటే ఫాజన్స్ రూల్స్ మీద మనకు ప్రాబ్లం వేసే అవకాశం ఉంటుంది. నెక్స్ట్ వన్ హియర్ మాలిక్యులర్ ఆర్బిటాల్ థియరీ మీద క్వశ్చన్స్ అడుగుతూ ఉంటాడు. దెన్ డైపోల్ మూమెంట్, నేను ఏవైతే సర్కిల్ చేశానో వాటి మీద కొద్దిగా ఎక్కువ స్ట్రెచ్ చేయండి. సో వాటి మీద ఎక్కువగా మనకు క్వశ్చన్స్ అడిగేటటువంటి అవకాశము ఉంటుంది. ఇస్ ఇట్ రైట్? సో అంటే నేను చెప్తూ ఉంటాను, ఇవన్నీ చెప్పుకుంటూ పోతున్నాను. బట్ ఏంటంటే మీరు సో ఈ పాయింట్స్ వచ్చినప్పుడు కొద్దిగా అలర్ట్ గా ఉండడానికి ప్రయత్నించండి. ఓకే. సో ఫస్ట్ థింగ్ ఈస్ సో ionic bond. Ionic bond. So ionic bond is nothing but a strong attraction forces, a strong electrostatic attraction forces present between oppositely charged ions is called as ionic bond. M plus ion undi nana, X minus ion undi, they are so positive ion and negative ion. So here highly positive ion, here highly negative ion. So this is a positive ion and negative ion. They are strongly attracted to each other. So whenever it is a strong electrostatic attraction forces present between oppositely charged ions, so this is M plus ion and X minus ion. This is represented as what is about here ionic bond. So ionic bond is nothing but a strong, ఇది గుర్తుపెట్టుకోవాలి, electrostatic attraction forces. A strong electrostatic attraction forces present between oppositely charged ions is called as ionic bond. Here metals and this is for non-metal. So here it is a metal. This is for non-metal. Next one here, low ionization potential. Next one here, high electron affinity. High electron affinity. Next one here, positive ion. Positive metal ion or positive charge. So here negative charge, negative non-metals. So positive metals, so positive charged metals. So highly electropositive, highly electronegative. So these are what is about here formation of ionic bond. In that one, the metal ions have loses one electron. The electron is shifted from metal to non-metal. Electron is transferred from metal to non-metal. Sorry. The metal is loses electron to formation of M plus ion. X is gaining of electron. It is X minus ion. So M plus ion and X minus ion, they have attract with strong electrostatic attraction forces. So presence of the strong electrostatic attraction forces, so it is a formation of what is about here ionic bond. ఇది ionic bond ను ఏర్పరుస్తుంది. అంటే strong electrostatic attraction forces, electron transfer. So here ఇంకో రకంగా ఏం చెప్పవచ్చు ఇప్పుడు, electron transfer from what is about here metal to non-metals. Non-metals. So this is a metals to non-metals. So they are, what is about here? Electrostatic, a strong electrostatic attraction forces. And a ionic bond is formed between metal to non-metal, low ionization potential with high electron affinity, electropositive metal to, so electronegative non-metals. So they are formation of ionic bond. So here, suppose we take simple example, sodium chloride. Sodium, so this is plus, what is about here? Chlorine. So actually based on that, what we write here, the electronic configuration of sodium is, so neon core. This is for 3s1. Chlorine is a neon core, so 3s2, 3p5. So here, ఇది ఇన్నర్ట్ గ్యాస్ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ పొందాలంటే ఒక ఎలక్ట్రాన్ దీనికి రిక్వైర్డ్. ఇది ఇన్నర్ట్ గ్యాస్ నియాన్ ఎలక్ట్రాన్ కాన్ఫిగరేషన్ పొందాలంటే ఒక ఎలక్ట్రాన్ ఏం కావాలి, ఇది కోల్పోవాలి. సో వన్ ఆఫ్ ది ఎలక్ట్రాన్ is shifted from, this is the electron. Here several electrons are present in their valence shell. One electron shifted from sodium to chlorine. One electron transfer from sodium to chlorine. So it is represented as, what is about here? Sodium chloride as a ionic compound. So ionic bond is indicated by, so oppositely charged ions. అంటే మామూలుగా మనం కోవలెంట్ బాండ్ ఏం చేస్తాం, ఒక గీతతో సూచిస్తాం నాన్న. కోఆర్డినేట్ కోవలెంట్ బాండ్ ను డోనార్ టు యాక్సెప్టార్ ఆరో మార్క్ తో సూచిస్తాం. హైడ్రోజన్ బాండ్ ను డాటెడ్ లైన్ తో సూచిస్తాం. బట్ సో హియర్ అయానిక్ బాండ్ ఈస్ ఇండికేటెడ్ బై, సో వాట్ ఈస్ అబౌట్ హియర్? పాజిటివ్ and negative charges. It is denoted by charges. So this is regarding about here bond. So what is about here the properties of ionic compounds? So ionic compounds, they may be exist as solid state. So this is a crystalline solids. Crystalline solids. So here, so what is about here? They are ionic nature. The ionic nature is depends on what is about here. So anions and cations. So what is about here, sir? Size of the cation is increases, ionic nature is increased. Sorry. So they are, what is about here? Now discussed later. So brief, so in-depth method. So generally they have high melting points. High melting points. Next one here, they are soluble in water. They are soluble in water. Next one here, so bad conductors. Bad conductors in solid state. Solid state. But in aqueous state, it is a good conductor of electricity. And bad conductors in solid state, good conductors in electricity. So they are soluble in water. They have high melting point. They are crystalline solids. So these are somewhat physical characters. Okay. These are somewhat physical characters for ionic compound. So what is about here? So next class. Okay. Nana? Hello?
Sir. Yes, sir.
ఓకే, నెక్స్ట్ సార్ వస్తాడు కావచ్చు. ఇప్పుడు దీని మీద ఇప్పటి వరకు ఏమన్నా డౌట్స్ ఉన్నాయా చెప్పండి రిగార్డింగ్ హలో
No, sir.
నో ఓకే సో యాక్చువల్లీ ఇప్పుడు మనం ఏంటంటే ఇప్పుడు సాలిడ్ స్టేట్ లో ఇప్పుడు సాలిబిలిటీ ఉంది కదరా నాన్న సో సాలిబిలిటీ మీద నేను ఇంకా డెప్త్ గా నేను మీకు ఎక్స్ప్లెయిన్ చేయవలసి వస్తుంది దట్ ఈస్ నథింగ్ బట్ సో హియర్ hydration energy. So which one ions are more hydration energy? So here the lithium salts are more hydration energy comparatively with others annamata. And ఇప్పుడు lithium chloride ఉంది, sodium chloride, potassium chloride, rubidium chloride, cesium chloride. They are soluble in water. Okay, whenever it is soluble in water, to liberate some energy that is called as hydration energy. The hydration energies are decreases from lithium chloride to cesium chloride. Which one is more hydration energy? Lithium chloride is more hydration energy. So hydration energy is nothing but సార్ వచ్చిన తర్వాత నాకు చెప్పండి బిడ్డ.
సార్ నమస్కారం సార్, వచ్చాను సార్.
సార్ నమస్కారం సార్. ఓకే ఓకే సార్, నేను
అంటే ఈరోజు ఫస్ట్ క్లాస్ కదా కొంచెం
ఓకే సార్ స్లోగానే లీవ్ అవుతానులేండి.
ఓకే, మీరు వాడేది ఏంటి సార్? ట్యాబా సార్ అది?
నేనా సార్ ఇది ఎక్స్పెన్ వాడుతున్నాను సార్.
ఎక్స్పెన్
అంటే ఇది ఒక అంటే మామూలు చిన్న బోర్డ్ లాగా పనిచేస్తుంది అది.
స్లేటా సార్? స్లేట్ లాగా?
స్లేట్.
ఓకే,
లైక్ ఏ స్లేట్ అంతే సార్.
అంటే ఎక్కడ దానికి అడ్రస్ ఇవ్వండి సార్, నేను కూడా తెప్పిస్తాను. లేదు
అయితే సార్ ఇది ఆన్లైన్ అంటే మామూలుగా షాప్స్లో దొరుకుతుంది, లేదా మీరు ఆన్లైన్ లో కూడా సార్ సెర్చ్ చేస్తే దొరుకుతుంది. అది తెప్పిస్తా అంటే మామూలుగా 3000 నుండి ఇక ఉన్నాయి సార్ రేట్స్.
ఎక్స్పెన్
అంటారు.
థ్యాంక్ యూ సార్.
సార్ ఓకే సార్. అయితే కొద్దిగా ఇది స్టార్టింగ్ లో కొద్దిగా ఇబ్బంది అవుతుంది సార్, మనం వాడుతూ ఉంటే కొద్దిగా.
మీరు బాగా రాస్తున్నారు.
ఓకే సార్, థ్యాంక్ యూ సార్.
థ్యాంక్ యూ సార్.
ఓకే.
హోస్ట్ నాకు ఇవ్వండి సార్.
ఓకే సార్, మీకుంది సార్. ఓకే,
ఏదయానంద్.
ఓకే సార్. ఓకే సార్.
ఓకే, హోస్ట్ చేసారా సార్?
చేశాను సార్.
ఓకే, థ్యాంక్ యూ సార్.
ఓకే సార్, థ్యాంక్ యూ.
హలో స్టూడెంట్స్,
రాసుకోవాలని.
ఓకే, thank you Mogili sir for giving me this opportunity. Let us discuss something about first topic which we are going to discuss is electrophilic addition reactions.
Good morning.
Anna, good morning.
Namaste.
Namaste.
Ade ippudu join ayalli malli
appudu first beginning lo join ayana.
Okay. అయితే ఇక్కడ పవర్ పాయింట్ బై మళ్ళీ హోస్ట్ చేస్తా. మొగిలి సార్ కో-హోస్ట్ చేస్తారు. మొగిలి సార్ ల్యాప్టాప్ అట్లనే ఉంచుతారా మీరు?
నేను తీసేస్తా సార్.
మీరు పని చేయండి, దయానంద్ సార్ ని హోస్ట్ చేయండి. ఒకసారి
హోస్ట్ చేశాను.
కాదు హోస్ట్ చేయండి. ఇంకా తర్వాత అయిపోయిన తర్వాత లీవ్ చేస్తే అయిపోతుంది. పవర్ మా దగ్గర కూడా పవర్ పోయింది. లేకుంటే ఓకే రైట్ రీక్లెయిమ్ హోస్ట్ ఉందా? ఓకే నేను చేస్తున్నానండి. ఓకే చేస్తాను.
చేయండి
డన్.
సార్. నేను లీవ్ కావచ్చా?
కావచ్చు సార్ ఇప్పుడు. థ్యాంక్ యూ.
ఓకే
భయ్యా ఒక్క నిమిషం దయానంద్ భాయ్.
ఓకే.
Good evening, students. I'm very much privileged and happy to invite one more research person, Dr. A. Dayanand. Has been working at Government City College, Hyderabad, as assistant professor of chemistry. Wide area of teaching experience. He has worked at various levels. Nana, metal mat. ఏంట్రా మీట్ అవ్వట్లేదు. అంకుల్ హోస్ట్ చేశాను. భయ్యా మీరే ఒకసారి అందరిని మీట్ చేయండి. అంటే నేను మళ్ళా నన్ను ఒకసారి కోచ్ చేయండి ఒక్క నిమిషం. ఓకే బాయ్ స్టార్ట్ చేసాను. థ్యాంక్ యూ భయ్యా. థ్యాంక్ యూ వెరీ మచ్ ఫర్ మనకి
Hello students. I think you can follow me. I think here I am A. Dayanand. As I was saying about me, I am going to discuss something about electrophilic addition reactions and others. That is electrophiles. What are electrophiles? Electrophiles are those chemical species which attract or which are having affinity to attract electrons. Okay, let us see about different types of reactions. That is, we know that we are having nucleophiles are there, electrophiles are there, okay, free radicals are there. Okay, there like that we are having many. First of all, let us see about electrophiles. The reactions involving electrophiles are again, that is, electrophilic addition reactions are there. Okay, that is electrophilic addition reactions can take place with towards an unsaturated compound like alkenes. Okay, or they can take place even with alkynes, triple bond containing compounds also. Okay, then okay, first of all, let us see some general example. Okay, here if you see this electrophilic addition reaction that is there in this on the screen, is ethylene is reacted with bromine. 1,2-dibromoethane is formed. Okay, then none of these two is charged, but the reaction is taking place. Okay, therefore here 1,2-dibromoethane is formed. Therefore, we can say that the bromine has a low energy empty orbital, therefore is an electrophile. Now, Br bond is there, is exceptionally weak. Therefore, bromine reacts with many nucleophiles like this. Here it is a nucleophile. Okay, therefore here bromine is a electrophile. I think you got an idea about electrophiles and nucleophiles. Okay, that is here, whichever is attracting the electrons is called as an electrophile, and whichever is attracting the positive charge is called as a nucleophile. Then simple unconjugated alkenes are nucleophilic and react with electrophiles. Okay, for example, alkene is a nucleophile. Okay, what is our aim? Our aim is to answer some questions in a JAM paper. Okay, therefore here what you have to do is you try to learn some of the important aspects. What is an electrophile? What is a nucleophile, like this? Here, whenever there is a reaction, you know that the orbitals are going to interact. Okay, because of the interaction between the orbitals only the reaction takes place. Okay, for example, here alkene is a nucleophile. It is having filled pi orbitals are there. Electrons are there in this pi orbital. Whereas LUMO is, that is the lowest unoccupied molecular orbital is there in bromine. It is having an empty sigma star orbital. It is an electrophile. When the reaction takes place, they are going to interact. That is, this pi orbital, HOMO and LUMO are going to interact to form a cyclobromonium ion. Okay, that is bromonium ion is formed. Okay, therefore here bromine is going to develop a positive charge. bromonium is an electrophilic center is created. Okay, the bond between bromine and bromine is very weak. Therefore, electrophilic addition is going to take place between them. Then, for example, okay, that is, if you take this alkene with a oxygen in the atmosphere of oxygen, it forms an epoxide. Okay, the common oxidants in this reaction are generally, what are the common oxidants are? Peroxy acids are the common acids. Okay, these are the peroxy carboxylic acids generally undergo or generally result in the formation of an epoxide. Okay, that is this pi bond that is there is going to form an epoxide is formed. How the reaction takes place, the nucleophile is going to, what is the nucleophile here? This itself, this alkene itself is called as a nucleophile now. Okay, this alkene is called as the nucleophile and it is going to attack this peroxy oxygen and finally our carboxylate group is formed and this epoxide or OH group is going to be formed, this one. Then here, if you take an alkene, cyclohexene, metachloroperoxybenzoic acid, this is very important reaction. This MCPBA, otherwise called as metachloroperoxybenzoic acid, is going to, that is having a peroxy bond, therefore it forms this epoxide. Okay, that is epoxide is formed and the remaining is going to form a, that is a benzoic acid derivative, metachlorobenzoic acid is formed. Okay, again the same homo-lumo concept is going to be the main involvement in this one for the formation of the chemical bond and epoxide is formed. Okay, that is here the cis epoxidation is going to take place. Okay, that is on one side, it is going to attack, therefore the, if at all there are two alkyl groups, these two branches are going to be protruded towards one side. Okay, that is epoxidation is a, we can say that epoxidation is an electrophilic addition reaction that we can have concluded by those reactions. If you see the epoxidation is stereospecific. What is meant by stereospecific reaction? A reaction in which a product is going to give only one of the isomer. Okay, if the product, if one of the reactant, the reactant is going to give a specific reactant. For example, here we are having cis alkene. Cis alkene is going to give this isomer. Okay, that is in which all the alkanes, that is alkyl groups are protruded towards one side. Why? Because it is a cis alkene. Therefore, epoxidation is going to give this epoxide. And this is the transition state for this epoxide. Why? Because the oxygen is going to be transferred. See here, this is the transfer. Draw this. Okay, then cis-stilbene. Okay, my dear students, all the reactions that are going to be presented in this presentation are going to appear in the exam directly. Why? Because all these reactions are taken from a reference book. There cis-stilbene is there. Okay, that is a metachloroperoxybenzoic acid. It gives cis-stilbene oxide is formed. Cis-stilbene oxide is formed. Okay, and this is a trans-stilbene. If you take trans-stilbene oxide, such reactions in which a reactant, okay, an isomer is going to give only one of the product, the mixture of the products are not formed. Such reactions are said to be stereospecific reactions. Okay, stereospecific ante oka reactant oka product ne istundi, oka isomer oka product ne istundi, oka క్రియాజన్యాన్ని మాత్రమే ఏర్పరుస్తుంది. దాన్ని స్టీరియోస్పెసిఫిక్ రియాక్షన్స్ అంటాం. సిస్ ఆల్కిన్ గివ్స్ సిస్ epoxide, trans alkene gives trans epoxide. Okay, therefore they are said to be stereospecific. Okay, therefore we can say that electrophilic additions are stereospecific in nature, especially epoxidation reactions. Okay, then more substituted alkenes epoxidize faster. Okay, then let us see about this concept, that is more substituted alkenes are going to be epoxidized faster. Why? Because more substituted double bonds are more stable, therefore they are more nucleophilic. Okay, that is, for example, this is ethylene, there are no, that is branches, or there are no substitutions, therefore it is going to be very weak. It is not fast in the substitute epoxidation reaction, whereas this one is having very high rate of epoxidation. Okay, it is going to epoxidize faster because of the extra stability or of caused by the methyl groups. All the methyl groups are going to epoxidize it faster. More substituted double bonds are more stable because they are more nucleophilic. Why they are more nucleophilic? I think you know all this. Methyl is a plus I affecting group. They are going to increase the electron density in the HOMO of this alkene. Therefore, it is going to be formed. It results in the formation of high nucleophilic nature of this alkene. ఓకే, ఇక్కడ ఎప్పుడైతే ఆల్కైల్ గ్రూప్స్ ఎక్కువ ఉంటే రియాక్టివిటీ ఎక్కువ ఉంటుందని చెప్తున్నాం మనం. ఓకే, జస్ట్ ద సేమ్ థింగ్ ఈజ్ ఎక్స్ప్లెయిన్డ్ ఇన్ దిస్ మాలిక్యులర్ ఆర్బిటాల్ డయాగ్రామ్. ఓకే, దట్ ఈస్ హియర్ when interaction each rises the HOMO and increases nucleophilicity. Alkyl groups పెరుగుతుంటే nucleophilicity కూడా పెరుగుతుంది. A tetra substituted alkene reacts in preference to a cis disubstituted alkene. Okay, that is, even when two alkenes are equally substituted, the effect of epoxidizing one of them is to reduce the nucleophilicity of the second. Okay, for example, here if you take MC1 equivalent, it is going to form an epoxide like this. Okay, then the other one is not epoxidized further. ఒకసారి ఒక దగ్గర epoxidize అయితే ఇంకో దగ్గర కాదు అని చెప్తున్నాడు అనమాట. ఎందుకంటే ఇక్కడ ఒకసారి ఫామ్ అయితే రియాక్షన్ లో వన్స్ ఇట్ ఈస్ ఇన్వాల్వ్ ద న్యూక్లియోఫిలిసిటీ ఆఫ్ ద అదర్ ఈస్ డిక్రీస్డ్. ఓకే, ఆక్సీస్పైరోపెంటేన్. Okay, para-nitro-peroxybenzoic acid is dangerously explosive and it is sufficiently reactive to produce this remarkable and highly strained spiroepoxide. Then spiroepoxide and antam. Okay, that is here we are preparing a spiro compound by using the same peroxybenzoic acid derivatives are used. They are called as oxyspiropentanes. Then another one is regioselectivity of electrophilic addition. I think you had heard about this Markovnikov's rule comes into picture here. Whenever in electrophilic additions, that is, if you see this one, this is an cyclohexene. Cyclohexene on electrophilic attack with HBr, that is hydrogen bromide. What is going to form? Here this pi bond is going to be attacking this hydrogen, and the hydrogen will attack on one of this carbon. Why? Because both are symmetrical carbons. This is called as symmetrical alkene. This symmetrical alkene is going to form a carbocation like this. And the next stage is attack of the bromide. Okay, that is in the first stage is the attack of the H plus is going to take place. HBr reacts as an electrophile. It is attacked at hydrogen, losing bromide ion. Unlike the bromine atom, hydrogen atom can't form a three-membered ring cation. It has no lone pairs to use. So electrophilic addition to a proton gives a product best represented as a carbocation. We know that in the carbocations, which are more stable, the carbocations, the stability order is tertiary is more stable than secondary, then primary. Okay, this is the order of the stability of these carbocations. Okay, then here there is no such possibility. Why? Because we are using, that is a symmetrical alkene. For example, if you take styrene, this styrene, what are the two possibilities? The hydrogen can attack. If you don't know about this Markovnikov's rule, we assume that the hydrogen, if it attacks at this position, the bromine should be, instead of this bromine, the bromine should be at this position. Okay, bromine ikkada undali. Okay, why? Because it is an unsymmetrical alkene. Okay, but according to Markovnikov's rule, what does this Markovnikov's rule says? The negative part of the addendum is attached to the carbon having, that is, less number of hydrogens. What is the negative part of the addendum? H plus. Okay, one is H plus, another one is Br minus. Okay, Br minus is going to attack on the high carbon. There are two carbons. One is this carbon, another one is this carbon. There are two terminal alkene, that is double bond or sp2 hybridized carbons. We know that in an alkene, sp2 hybridization takes place. Therefore, the bromide, if that is according to the Markovnikov's rule, it should attack at this carbon. Why? Because the hydrogens rich becomes richer. This carbon is having how many hydrogens here? Two hydrogens. Whereas this carbon is having only one hydrogen is there to this carbon. Therefore, according to Markovnikov's rule, a carbon atom which is having higher number of hydrogens, to that only the hydrogen is going to be bonded. Okay, that is resulting in the formation of this one. Or the negative part of the addendum is attached to the carbon having less number of hydrogens. Okay, that is why. Now let us see the reason behind this one. Or else if you see this isobutene is going to give tertiary butyl bromide. Okay, all these are nothing but following Markovnikov's rule. This is called a regioselectivity. That is, the formation of the substitution taking place at a particular region. Only that product is formed. That is called as regioselectivity. Alkenes are said to be unsymmetrical here. Okay, this is styrene. One bromo, just now we had seen. This one is going to form a carbocation. Stabilized benzylic carbocation is more stable. Whereas if you take up this one, this is not going to be formed because it is going to be resulting in the formation of primary carbocation. Whereas here it is a secondary carbocation and which is more stable because of the phenyl or benzene ring. This benzene ring is having alternate double bonds. Therefore, this carbocation that is formed here is stabilized. Benzylic carbocation is said to have more stability. Okay, then anyhow, it is secondary carbocation, therefore it is more stable. Okay, therefore it is going to result in the form of this one. This is called as Markovnikov's rule. Markovnikov's rule explains the regioselectivity of this electrophilic addition reactions. This product is not formed. Okay, I think, are you following me? If you follow me, type 1. If you don't follow me, type 2 so that I will repeat again. Okay, let us learn it coolly and slowly so that let us answer the questions in the examination paper. That is the Markovnikov's rule. The hydrogen ends up attached to the carbon of the double bond that had more hydrogens to start with. Hydrogen ends up attached to the carbon of the double bond. Here we are having a double bond. Okay, thank you. Okay, that is, here it is going to be added to the double bond. Therefore, here we are having two carbons, but it is a symmetrical one, having equal number. But here the carbocation formation is more stable at this position. Okay, at this position only it is more stable. Therefore, it is going to be forming a substitution at this carbon only. Okay, if you see this one, here it is protonation leads to stable tertiary carbocation. This is a tertiary carbocation. Loss of this proton takes place. Okay, that is alkene is formed finally. Okay, that is isomerization is taking place here because of this, again because of Markovnikov's rule only. That is, hydrogen should be bonded only to this terminal hydrogen. Okay, this at this only it is bonded. If it had bonded here, somewhere here, there will not be any chance for this formation of this isomerization results, will not be resulted. Okay, isomerization is not going to be formed. That is about this Markovnikov's rule. Okay, that is what is going to happen is acid is promoting this isomerization. Okay, acid is resulting in the formation of this isomer product. Acid catalyzed isomerization. Okay, for example, E-alkene. Okay, my dear students, we had seen epoxidation. After that, we had seen stereospecificity. What are stereospecific compounds? And the third aspect we are going to see is about Markovnikov's rule. And the fourth concept we are learning is acid catalyzed isomerization. It is also an electrophilic addition, as we had seen just now. It is resulting in the formation of this isomers. Okay, that is 95% E alkene is formed. Okay, that is 95% E alkene is formed. Okay, that is here, if you take up this alcoholic compound, elimination, even elimination takes place, OH is removed, and a cation is formed. This results in two types of compounds. One is E alkene, another one is Z alkene. E and Z interconvert, and via a carbocation intermediate is the intermediate that is involved here. Okay. Now let us see this again. HCl addition. HCl will be added according to the Markovnikov's rule only. HCl is added to the second carbon, secondary, resulting in the, why? Because it is more stable. If it is added, H is added to the terminal carbon, it is resulting in the secondary cation. If it is added to the middle carbon, it results in the primary carbocation. We know that secondary is more stable than primary. Therefore, it is giving 2-chloropropane is formed. Similarly, HI, hydrogen iodide addition, also results in iodocyclohexane. Okay, that is thiols. To form thiols, H2S is added to form thiols. SH is formed. SH is going to be the, that is the electrophile. Okay, it is going to H plus is attacked. H plus is the electrophile. After that, this nucleophile SH minus is going to be attacking this one. Okay, the first step is a slow step. Therefore, it is called as the rate determining step. Here, this is a slow step. The first step is the slowest step, and the next step is very fast step. This step is very fast. The first step, modati dashane chala rate nirdharana dasha ani antam. Okay, let us take another example. Isoprene. Isoprene again is going to form this compound. Protonates here at this juncture. Ikkada mana protonation avutundi. Okay, at one point. Why? Because the second one is having least number of hydrogens. Markovnikov's rule says that it should be added at the carbon having high number of hydrogens. Okay, it is resulting in the formation of this carbocation is formed. E carbocation is tertiary. Ikkadaithe secondary. Okay, therefore, which is more preferable? Tertiary route is more preferable. That is why it is the route that is followed. This will not be followed. Okay, therefore, bromination. Okay, that is called as this bromination will take place at this. Why? Because there it is stabilized by means of conjugation. The cation, by protonating the other double bond, is also allylic, but it cannot benefit from the additional stabilization. As I said, ikkada stabilization ledu, ikkada stabilization unnadi. Sthirikaramu anedi undi, sthiramunga untundi idi. Okay, that is, it is stabilized because tertiary carbocation is formed. Okay, whereas here from the methyl group, because the positive charge is just ikkada nundi anni involve aithayi. Okay, that is here, this is the carbocation, and the bromination is taking place. It is called as prenyl bromide. Okay, that is, bromination will take place at 1 and 4. This is called as conjugate addition. దీన్ని మనం కాంజుగేట్ అడిషన్ అని కూడా అనొచ్చు. ఓకే, బ్రోమిన్ ఫస్ట్ బ్రోమిన్ ఒక దగ్గర బాండ్ అవుతుంది. తర్వాత కాంజుగేషన్ వలన మరొక దగ్గరికి కూడా బ్రోమిన్ వస్తుంది. Okay, this is called as conjugate addition. Okay, that is about this one. Then this is a thermodynamic product. It has more substituted double bond. This is the kinetic product. By heating చేస్తే ఏది స్టేబుల్ అది వస్తే దాన్ని స్టేబుల్ కాంపౌండ్ ఏర్పడడాన్ని ఏమంటాం? థర్మోడైనమిక్ ప్రోడక్ట్ అంటాం. ఇట్ హ్యాస్ మోర్ సబ్స్టిట్యూటెడ్ డబుల్ బాండ్ అండ్ 2 large bromine atoms are further apart. చాలా దూరంగా ఉన్నాయి. ఇది లెస్ స్టేబుల్ కానీ తొందరగా ఏర్పడుతుంది కాబట్టి ఇది కైనెటిక్ ప్రోడక్ట్. గుర్తుంచుకోండి ద డిఫరెన్స్ బిట్వీన్ థర్మోడైనమిక్ ప్రోడక్ట్ అండ్ కైనెటిక్ ప్రోడక్ట్. హీట్ చేస్తే ఎప్పుడైనా హీట్ చేస్తే ఏమవుతుంది? మనకు ఎక్కువ స్థిరంగా ఉన్న కాంపౌండ్ ఏర్పడుతుంది. ద హయ్యర్ స్టేబుల్ కాంపౌండ్ ఈస్ ఫార్మ్. whereas if you very low temperatures, lesser stable compound is formed. Okay, then the regioselectivity of bromination. Okay, same product whichever end is attacked. Okay, bromination lo chuddam manam. Bromine Br2 తో cyclobromonium ion is formed. In the next step is bromide attack is going to take place. Why this bromine Br bond is very weak? In the first step, it is acting as this bromine atom is acting as an electrophile. Appudu cyclobromonium ion vastundi. Same product is formed whichever end is attacked. Ekkadaina, why? Because we are having same 1,2 dibromo. Okay, then if you take up instead of bromine kaakunda methyl alcohol, if you take the solvent as methyl alcohol, we are going to get OMe at this end. Okay, that is departure of the leaving group takes place. This is the leaving group. It is going to be left over. We will see about the leaving groups in SN1, SN2 mechanisms. Okay, therefore here this is a carbocation formed. Carbocation ikkada attack aithe idi stable SN1 reaction low అంటే unimolecular nucleophilic substitutions will require the stable carbocation. అదే SN2 రియాక్షన్ అయిందనుకోండి, SN2 లో ఏమైతుంది మనకు వెంటనే in a single step it is going to be removed. Therefore this is the product. Okay, departure of the leaving group, bromine and methyl alcohol, methanol attacks at the more substituted end of the bromonium ion. Okay, that is about this reaction. That is in the presence of methyl alcohol, ఈ రియాక్షన్ కనుక this reaction methyl alcohol medium లో చేస్తే మనకి ఈ ప్రోడక్ట్ వస్తుంది. Okay, that is methyl alcohol is binding or attacking at this carbon. The transition state has considerable positive charge and is known to as a loose SN2 transition state. Okay, bromine, bromohydrin, H2O తో చేస్తే OH is going to be bonded to this carbon again. Okay, NaOH and epoxidation will be resulted also. Okay, bromine, H2O followed by NaOH. It is resulting in the formation of an epoxide. Okay, epoxide as we had seen just now. Bromine, methyl alcohol. Relative rates of alkenes with bromine in methanol. Okay, bromine followed by methanol. The reaction. The higher the substitution, the more the reaction rate. Substitution ekkunte reaction rate ekkuva. Okay. Regioselectivity of epoxide opening. Okay, this is very important. Okay, epoxide opening ఎటువైపు ఉంటుంది? Reaction of epoxide with acidic methyl alcohol, acidic medium లో తీసుకుంటే the higher substituted carbon will get the reverse is going to take place. Protonation by acid produces a positively charged intermediate. చాలా ఇంపార్టెంట్ మై డియర్ స్టూడెంట్స్. ఇది epoxide opening ఎటువైపు ఉంటుంది? As we had seen epoxide already, how the epoxide is going to be opened, ఎటువైపు ఓపెన్ అవుతుంది అనేది కూడా ఇంపార్టెంట్. Protonation by acid produces a positively charged intermediate that bears a that is protonation. The first step, protonation takes place. Therefore, in the acid medium protonation kabatti carbocation is formed at this carbon. Positive center is formed at this carbon. This is nothing but tertiary carbon. Therefore, it is more stable. And the next step, OMe, that is methoxide, in the form of methanol, is going to attack on this one, resulting in this substituted end. If it is in the basic medium, nucleophile approaches less hindered end. It is acting as a nucleophile. Okay, that is a strong nucleophile. Earlier, or it is a base. Okay, it is going to attack in base. There is no protonation of the epoxide and no buildup of the positive charge. Without protonation, the epoxide oxygen is a poor leaving group and leaves only if pushed by the strong nucleophile. It is acting as a nucleophile. The reaction becomes pure SN2 reaction only. Steric entrance becomes the controlling factor. Sorry, mechanism anta pakkku pettina epoxide anangane ide adugutadu eppudaina ring opening. Epoxide ring open kavalante acid medium unnattaithe more substituted methoxide is formed, or more substituted end దగ్గర ఈ solvent is molecule will attack. అదే బేసిక్ మీడియంలో అయితే లెస్ సబ్స్టిట్యూటెడ్ ఎండ్, అంటే ఆక్సిజన్ విల్ గో టువర్డ్స్ మోర్ సబ్స్టిట్యూటెడ్ ఎండ్. Okay, why? Because it is acting as a, that is a nucleophile. Here it is acting as a base. Methoxide is a strong base, basic methoxide. Okay, nucleophile veru, ఇది వేరు. Then HBr and H2 again చూడండి ఇక్కడ, it is again attacking at the more substituted end. Here this is the carbon which is having one substituent. ఇది దగ్గర ఒక్క కార్బన్ కూడా లేదు, రెండు హైడ్రోజన్ ఉన్నాయి. ఇక్కడ it is having one hydrogen. Therefore, it is attacking at this end. The OH is attacking at this end in acid medium. Which is the acid here? HBr is the acid. Regioselectivity is not simple because SN2 substitution at a primary center is fast. Bromide is acid attack the epoxide below, mainly at the less substituted end. Okay. It is going to attack at the less substituted end. Why? Because మనకు SN2 రియాక్షన్స్ అన్ని కూడా తెలుసు, ఆ తర్వాత చూద్దాం. SN2 ప్రైమరీ ఎక్కువ ఉంటాయి, SN2 is more active దేనికంటే సెకండరీ కంటే. అంటే ఇక్కడ ప్రైమరీ అంటే ఇది is the primary carbon, ఇది tertiary carbon. Therefore, it is attacking at this primary end. Okay, here bromide is attacking at this end, the acid medium. Electrophilic additions are stereospecific. Already we had seen about the stereospecificity in when you take a trans alkene, cis alkene. Stereospecific means ఒక రియాక్టెంట్ ఒక ప్రొడక్ట్ నే ఇస్తుంది, ఒక ఐసోమర్ నే ఇస్తుంది. ఓకే, దట్ ఈస్ హియర్ we are having cis epoxide, అన్ని ఒక్క దిక్కే ఉన్నాయి. Okay, then it is attacking and it is giving again cis product. Okay, plus and minus, that is racemic mixture is formed. And when it is attacking at both the ends, there are two possibilities, equal possibility only. Okay, therefore it is giving two ends, two ends దగ్గర కూడా ఈక్వల్ పాసిబిలిటీ తోనే రియాక్ట్ అవుతాయి. Okay, dimethylamine. Okay, that is OH is there here. It is an SN2 reaction with inversion is taking place. It's SN2 reaction అంటే inversion ఖచ్చితంగా ఉంటుంది. Okay, plus minus product is formed. Okay, this is about the MCPBA. Any doubts? You can ask the doubt also. I will ask you, permit you to unmute. Electrophilic substitution, addition to alkenes to produce stereoisomers. Okay, in bromine, when cyclohexene is treated with bromine in CCl4, the racemic mixture is formed. Okay, the racemic anti-1,2-dibromocyclohexene is obtained exclusively. Okay, this is the racemic mixture is formed. Why? Because it is bromination is always, that is what is going to happen is bromination is not cis addition will not takes place. It is an anti-addition. Okay, why? Because cyclobromonium ion is formed followed by the attack of the bromide. Trans vibrosum. Therefore, inversion will take place. First, electrophilic addition resulting in the formation of cyclobromonium. Okay, cis. ఇది సిస్ ఉన్నట్టయితే మనకు రెసిమిక్ మిక్చర్ వస్తుంది. Okay, that is, it is cis on both sides. They are alkyl groups are on the same side. Therefore, we are getting a racemic mixture, plus and minus. Bromination of alkenes is stereospecific because geometry of the starting alkene determines which product is formed. Bromination of Z and E2-butene in acetic acid produces a single diastereomer in each case, and they are different. Okay, for example, if you take E isomer, this is nothing but Z isomer. Z ante cis equivalent. Okay, Z isomer is giving this product. Okay, that is on both sides. Bromines are on the opposite side. If you take E isomer, E ante trans ku equivalent. Trans ante ఒకవేళ ఈ cyclohexene లో కుదరదు కానీ some other compounds it is possible, you are going to get different product. Anti-addition occurs in both cases. Okay, that is why it is resulting in the ఇక్కడ చూడండి, ఇక్కడ ఈ Z butene, ఇది E butene. E butene అయితే ఈ product వస్తుంది. This product is formed. Okay, where the methyls are opposite side, bromines, whereas here both methyls are on the same side. Cis butene or Z2-butene. Okay, Z2-butene, and another one is, this one is E-butene. Okay, E-butene, and these two are different products. Such compounds or such reactions are called as stereospecific reactions. Okay, stereospecific reactions about the same, the diastereomers are different, is achiral. Okay, this is a chiral compound. Anti-addition. Okay, that is, it is a chiral compound is formed. Why? Because meso compound, ikkada meso ochindi. Why? Because already trans undi, trans ku anti add chestunnam. If you take add trans ku anti add chesthe manaku meso compound vastundi. It is optically inactive. Water opens the bromonium ion with inversion. Okay, N-bromosuccinamide, it is also a bromination takes place. This reagent is convenient source of bromonium ions, like N-bromosuccinamide, NBS. ఇంతకుముందు మనము బ్రోమినేషన్ అంటే ఇంకొక బ్రోమిన్ కూడా అటాక్ అవుతుంది, కానీ ఇక్కడ there is no possibility. Therefore, we are adding this bromine. This is a trans compound. Trans compound, when it is opened, bromine will be on opposite sides. They are anti-addition again. Next step lo manam H2O molecule. Why? Because we are taking the solvent is H2O and DMSO, dimethyl sulfoxide. Okay, this is the product that is formed. Okay, that is why, because it is always anti-addition. Okay, inversion takes place. N-bromosuccinamide generates only a low concentration of bromine. Okay, easily handled if the solvent is aprotic. Allylic addition kuda possibility untadi. Okay, that is, here we are adding these two. First of all, we are adding bromination taking place. Ikkada methyl unnadi. Ippudu OH will attack at this position only. Okay, why? Because this is the carbon having more number of carbons. Tertiary carbon. Okay, ring opening, epoxide lagane. The additional question of regioselectivity, the alcohol attacks at the more hindered end of the bromonium ion. where there can be greatest stabilization of the positive charge. Okay, ikkada positive charge stable ga untadi. SN2 reaction ainappatiki this is the product that is formed. And in okay, same as epoxide, it generates alcohols. Here also, it also generating the diol is formed. MCPBA H2O. That is perchloric acid and followed by inversion. Okay, that is inversion takes place. Osmium tetroxide also results in the formation of cis hydroxylation. Epoxide followed by H2O, HClO4 gives transipodiols. Ikkada cis diol is formed. The OH groups are on the same side of the double bond. Here, OH groups are on the opposite side of the double bond. Okay, these two are also useful for us. Osmium tetroxide addition helps in the cis hydroxylation. Okay, that is same side they are going to attack. Okay, that is osmium starts at tetrahedral osmium and ends in osmium 6. The immediate product of is an osmate ester, but these reactions are carried out in the presence of water and hydrolysis always on fast, giving the diol. This NMO, that is N-methyl morpholine N-oxide, is used to convert this osmium 6 నుండి మళ్ళీ osmium 8 convert చేయడానికి యూజ్ అవుతుందండి. NMO is a reagent that is useful here. Then again, stereospecificity of hydroxylation. Okay, epoxidation we had seen, Markovnikov's rule we had seen, bromination we had seen, and now we are seeing, this is also very important, hydroxylation. Whenever you come across addition anangane common ga gurtoche vandarki. Osmium, it is also stereospecific nature as osmium tetroxide. Okay, is a trans ku cis add cheste anti vastayi. Okay, that is same side they are going to attack. Okay, then Z alkene, this is E alkene, this is Z alkene, that is cis, almost equivalent to cis. Okay, anti-product is formed. Okay, that is anti-vipose and the opposite side, and already it is cis. Cis, we are adding osmium tetroxide. Okay, therefore it is giving this compound. Okay, osmium to an alkene syn fashion. The overall product depends on the geometry of the alkene starting material. It is stereospecific. It is stereospecific in nature. Breaking of double bond using ozonolysis is also one of the important reactions. Ozonolysis. Osmium tetroxide will give cis hydroxylation. Okay, on cis hydroxylation followed by sodium periodate. Okay, sodium periodate is going to break this bond into two fragments. Ikkada break ayipotundi. It is giving, this one is giving one aldehyde, this one is giving another aldehyde. Okay, that is two aldehydes are formed. This is about, okay, this is the same reaction will be possible using ozonolysis also. Intermediate లో కూడా ఉంటుంది మన ఓజోనాలిసిస్ లో కూడా ఇదే, అంటే ఆస్మియం టెట్రాక్సైడ్ కార్బోహైడ్రేట్స్ లో కూడా ఇదే రియాక్షన్. In carbohydrates also we are having OH groups adjacent to the two carbons. There also you are going to break this bond between the two carbons, resulting in the formation of an aldehyde. This is one aldehyde, this is another aldehyde. Okay, let us see about the next reaction, ozonolysis. What is ozone? This is the nothing but the ozone. This is the, that is the ozone isomerism. It is having a dipolar oxygen, O plus and minus. Okay, that is addition of ozone takes place, called as malozonide. Ozonide intermediate is formed, and this is going to break. Okay, this is going to cleave or dissociate at this end. And dimethyl sulfide or phosphine will remove this oxygen also, and resulting in two aldehyde groups. Ozone is symmetrical bent molecule with a central positively charged oxygen atom and 2 terminal oxygen atoms. We know that. Like osmium tetroxide, alkenes by a cyclic mechanism, 5-membered ring. Just now we had seen perovadate also we are having 5-membered ring. It is going to collapse by breaking the OO bond and a CC sigma bond, but gains 2 strong C double bond O groups. Okay, ozonolysis double bond ఎక్కడ ఉంటే అక్కడ బ్రేక్ అయిపోతుందని గుర్తుంచుకోవాలంతే. Okay, here RCHO is formed. This is RCHO. Here also RCHO, and we can convert into carboxylic acids also. If you use that is hydrogen peroxide, it gives carboxylic acid. అట్లా కాకుండా we can convert them into alcohols also by using sodium borohydrate. Sodium borohydride వాడితే reduce అయితే మొత్తం. It is giving alcohols. అంటే alkenes నుండి direct గా we can prepare alcohols, carboxylic acids, aldehydes. All these are addition reactions. Ozonolysis is helpful for it. Ozonolysis of cyclohexenes is particularly useful. 1,6-dicarbonyl compounds. ఇక్కడ బ్రేక్ అయిపోతుంది. H2O2 వాడితే కార్బాక్సిలిక్ యాసిడ్స్ వస్తాయని తెలుసు కాబట్టి డయోయిక్ యాసిడ్, అడిపిక్ యాసిడ్ నైలాన్ మ్యానుఫ్యాక్చర్లో కూడా వాడచ్చు. ఈ డైరెక్ట్ రియాక్షన్స్ వస్తాయి మనకు. దెన్ ఆక్సిమెర్క్యురేషన్, ఆక్సిజన్ ఈజ్ యాడెడ్ followed by mercury is also added. Okay, then here elimination in acid, HgOAc taken twice, sodium borohydrate. Okay, that is mercury is nothing but a transition metal. It is useful to make it more, to decrease the rate of the reaction. ఓకే, ఇక్కడ మెర్క్యూరీ ఒక ట్రాన్సిషన్ స్టేట్ ఫామ్ అవుతుంది. సైక్లోబ్రోమోనియం లాగానే మెర్క్యూరీనియం అయాన్ ఈస్ ఫామ్. ఓకే, మెర్క్యూరీనియం అయాన్ ఈస్ ఫామ్. దెన్ H2O కెన్ అటాక్ ఆన్ దిస్ వన్. ఎందుకంటే డబుల్ బాండ్ ఈస్ హ్యావింగ్ ఎలక్ట్రాన్స్. ఓకే, ఇట్ ఈస్ ఎలక్ట్రాన్ రిచ్ ఆల్రెడీ. ఓకే, therefore how can again H2O molecule can attack this one is just by decreasing the electron richness of this one. Okay, that is we require an electrophile to be attacked. Okay, then the question is how to get rid of this mercury. Replace Hg by using reducing agent. Last reducing agent తో తీసివేయచ్చు అంటారు. ఓకే, ఆక్సిమెర్క్యురేషన్ వల్ల ఏమవుతుందంటే OH, another one is hydrogen is formed. H2O hydrolysis డైరెక్ట్. H2O యాడ్ చేయలేం డైరెక్ట్ గా, ఎందుకంటే మెర్క్యూరీ ఏం చేస్తుందంటే H2Oలో లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్ ఉన్నాయి. ఇక్కడ కూడా డబుల్ బాండ్ లో కూడా ఇక్కడ 5 ఎలక్ట్రాన్స్ ఉన్నాయి. ఆల్రెడీ ఎలక్ట్రాన్ రిచ్ దానికి ఇది ఇవ్వలేము. ఓకే, therefore what we have to do is we have to reduce the electron density on this one by using mercury. And finally it is going to form this alcohol. Okay, OH minus H2O, Markovnikov of product is formed. See here, Markovnikov of product వచ్చింది. OH minus is attacking on this less hydrogen containing carbon. It is called as oxymercuration. Alkynes లో అయితే చాలా యూస్ఫుల్. చూడండి, alkynes లో అయితే addition reaction, again it is also an addition reaction. Okay, finally it is nothing but an electrophilic addition product is formed. Okay, here also this is very important reaction. Again ikkada OH is formed at this position and ikkada hydrogen vastundi. It is an enol. Enol will convert into aldehyde. Okay, it is converted into aldehyde by means of tautomerism. HgOAc taken twice, the product isolated from an alkyne oxymercuration. Actually it is a ketone. Okay, ఒకసారి చూడండి, ఇది మనము ఆల్కైన్ తీసుకున్నాం, H2O యాడ్ చేయాలి. H2O లో ఏముంటది, OH ఉంటది, ఇంకొకటి H ఉంటది. మన మార్కోనికఫ్స్ రూల్ ప్రకారము OH ఎక్కడ యాడ్ చేయాలి? ఈ కార్బన్ పైన యాడ్ చేయాలి. ఇది కార్బన్, ఇది కూడా కార్బనే. ఇక్కడ హైడ్రోజన్ యాడ్ చేయాలి, ఇక్కడ OH ను యాడ్ చేయాలి. అప్పుడు ఏమవుతుంది? ఒక డబుల్ బాండ్ తగ్గిపోతుంది. అంటే ఏమొస్తుంది అప్పుడు? COH డబుల్ బాండ్ CH2 వస్తుంది. ఇదే ప్రొడక్ట్. ఇది టాటామెరిజం చెంది ఇక్కడ ఉన్న హైడ్రోజన్ ఇటు వచ్చి, ఓకే, ఇక్కడ ఏమవుతుంది? ఇక్కడ హైడ్రోజన్ ఇటు వచ్చేస్తుంది, ఇటు వస్తుంది. ఈ డబుల్ బాండ్ ఇటు వస్తుంది. Finally, it is forming this aldehyde is formed or ketone is formed. Okay, or C double bond O or CH3. It is nothing but ketone is formed finally. For alkynes, okay, it is that is what type of alkyne it is? Acetylene అయితే మనకు aldehyde వస్తుంది. ఇది acetylene గా terminal alkyne. Okay, that is about this compound. Okay, what is the product that is required is in the final step లో మనకు సోడియం బోరోహైడ్రేట్ కూడా అవసరము. ఇక్కడ నుండి మనకు సోడియం బోరోహైడ్రేట్ is also required. ఇది ఆల్కైన్స్ మాత్రం తొందరగా అవుతుంది. ఇది ఒక ఇంపార్టెంట్ పాయింట్ ఏంటంటే, సారీ, ఇక్కడ ఫర్ ఆల్కైన్స్, ఫర్ ఆల్కీన్స్ అయితే సోడియం బోరోహైడ్రేట్ is required. For alkynes, there is no need of any sodium borohydride. Why? Because it readily undergoes this tautomerism and the removal of Hg. The product isolated is in fact a ketone is formed finally. Okay, తర్వాత hydroboration చాలా ఇంపార్టెంట్. ఇది కూడా hydroboration. Okay, hydroboration follows anti-Markovnikov's rule. That's most important. Anti-Markovnikov product is formed. What is hydroboration? Boron is again an electrophile. Why? Because it is having an empty p orbital. Generally, what are electrophiles? Electrophiles are those which are having empty orbitals or which are having positive charge. Okay, they are having positive charge. That like sodium plus electrophile gas. Sodium is already having filled orbital, therefore it is no more an electrophile. Okay, cyclopropene, okay, BH3 boron trihydride or B2H6 is a diborane antam. Okay, BH2H, okay, BH2, another one is hydrogen is bonded, alkyl boranes are formed. Okay, ఈ alkyl borane ఇక్కడ ఆగదు, మళ్ళీ ఇక్కడ రెండు మళ్ళీ సబ్స్టిట్యూట్ అవుతాయి. Trialkyl borane is finally formed. Okay, it is nothing but an alkene. It is going to form a BH2 and another mole, another ఇంకొక హైడ్రోజన్ మళ్ళీ అది సపరేట్ అవుతుంది. ఓకే, ఇక్కడ రెండు BHలు ఉన్నాయి కదా, ఇక్కడ ఒక H, ఇక్కడ ఒక H అనుకుందాం. ఈ రెండు BHలు, ఓకే, దట్ ఈస్ BH2 మైనస్. మన మార్కోనికఫ్స్ రూల్ ప్రకారం ఏం కావాలి ఇక్కడ? This is going to be bonded to this carbon and ikkada H. Okay, H minus, sorry, it is H minus. Okay, H minus and BH2 plus anukundam. Okay, BH2 మార్కోనికఫ్స్ ప్రకారం అయితే లాస్ట్ కి బాండ్ కావాలి, ఇక్కడ బాండ్ కావాలి. ఇది హైడ్రోజన్. మార్కోనికఫ్స్ కు వ్యతిరేకంగా ఫైనల్లీ ట్రైఆల్కైల్ బోరేన్ is formed. A trialkyl borane. What is going to happen to this trialkyl borane? Trialkyl borane, okay, Br2 trialkyl borane, H2O2 add చేసాం అనుకోండి, then H2O2 will finally give alcohol as the product. Alcohol, ఇక్కడ this is nothing but this alkene, ఇక్కడ OH వస్తుంది. Okay, ఇక్కడ లాస్ట్ కార్బన్ పైన OH వస్తుంది. ఓకే, మామూలు H2 అయితే ఏం కావాలి? OH will be bonding to this carbon. అంటే అప్పుడు ఏమవుతుంది? ఇది it is going to form a alcohol like this. It is going to form an alcohol like this. Whereas if you take up hydroboration route లో వెళ్తే మనకు OH ఎక్కడ అటాక్ అయింది? లాస్ట్ కార్బన్ పైన అటాక్ అయింది. This is against Markovnikov's rule. వాట్ డస్ అకార్డింగ్ టు మార్కోనికఫ్స్ రూల్ అయితే OH ఇక్కడ రావాలి, H ఇక్కడ రావాలి. ఓకే, ఇక్కడ మనకు మెకానిజం అడిగారు ఎంట్రన్స్ లో, కానీ డైబోరేన్ కనబడితే చాలు మనం ఏం రాయాలి, యాంటీ మార్కోనికఫ్ ప్రొడక్ట్ రాయాలి అంతే. ఓకే, డైబోరేన్ ఫాలోడ్ బై H2O2 రియాక్షన్, H2O2 అయితే ఇది వస్తుంది. This is called as hydroboration. Okay, there are many applications of electrophilic addition reactions. Okay, we had seen about MCPBA, that is epoxidation takes place. Osmium tetroxide will also give cis hydroxylation. Ozonolysis, that is diborane. Diborane will give anti-marconicaf product is formed for diborane. Okay, HBr route, cyclobromonium anti-addition. Okay, that is about them. Okay, that is about many of the reactions which we have seen. Okay, electrophilic additions are very, very important, my dear students. Okay, now let us see some more examples of electrophilic addition reactions, which generally we are going to have in our examination. Can anybody tell me what is the product for this one? ఇక్కడ తెలుగు చెప్పండి. ఇది CH3, ఇది ఒక కాంపౌండ్ ఆల్కీన్. ఈ ఆల్కీన్ కు HBr యాడ్ చేస్తున్నాం. HBr, then where the bromine will attack and hydrogen ఎక్కడ అటాక్ అవుతుంది చెప్పండి.
Sir, beside
ఎక్కడ ఇక్కడ ఏమైతుందంటే, ఇక్కడ ఫస్ట్ హైడ్రోజన్ ఈస్ గోయింగ్ టు అటాక్ ఆన్ దిస్ కార్బన్ H+. అప్పుడు ఏమైతుంది, ఇక్కడ కార్బోక్యాటయాన్ ప్లస్ చార్జ్ వస్తుంది, ఇక్కడ హైడ్రోజన్ అటాక్ అయింది అంతే కదా, రీఅరేంజ్మెంట్ అవుతుంది ఇక్కడ. అయితే టర్షరీ ఈజ్ మోర్ స్టేబుల్ అని తెలుసు మనకు కదా, టర్షరీ ఈజ్ మోర్, ఇక్కడ కూడా హైడ్రోజన్ ఉంది అంతే కదా. అప్పుడు ఏమవుతుంది, ఇక్కడ కూడా హైడ్రోజన్ ఉంది కాబట్టి ఈ హైడ్రోజన్ షిఫ్ట్ అవుతుంది, అది మారిపోతుంది అనమాట మొత్తం. మారిపోయిన తర్వాత ఇప్పుడు బ్రోమైడ్, ఇట్ ఈస్ గోయింగ్ టు ఫార్మ్ ఏ కార్బోక్యాటయాన్, టర్షరీ కార్బోక్యాటయాన్. ఓకే, రీఅరేంజ్మెంట్స్ కూడా ఇంపార్టెంటే ఎలక్ట్రోఫిలిక్ అడిషన్స్ లో. ఓకే, దెన్ ఇట్ ఈస్ CH2 కాబట్టి ఇప్పుడు ఏమైతుంది, ఇక్కడ ప్లస్ చార్జ్ వచ్చింది, ఇప్పుడు బ్రోమైడ్ విల్ అటాక్, Br minus will attack, therefore finally the product will be like this, Br product is formed. Okay, ఇంకొక రియాక్షన్ ఉంది, ఇక్కడ చెప్పండి. HCl, what will be the product? ఇక్కడ డబుల్ బాండ్ ఇట్లా కాకుండా డైరెక్ట్ ఇట్లనే ఉందనుకోండి, వాట్ విల్ బి ద ప్రొడక్ట్? HCl కానీ HBr కానీ. ఓకే, ఇంకా ఇంకొకటి, ఇది రెగ్యులర్ గా మేము ఎంట్రన్స్ రాస్తప్పుడు కూడా అడుగుతుండే ఈ క్వశ్చన్. అయితే ఇవన్నీ రీఅరేంజ్మెంట్స్ అంటాం, వాగ్నర్ మీర్విన్ రీఅరేంజ్మెంట్స్ అట్లా. What will be the product? HBr or HCl? The product here is, this is the product. ఇక్కడ Cl is attacked, Cl plus ఇక్కడ వచ్చేసింది, ఎందుకంటే హైడ్రోజన్ విల్ అటాక్ ఫస్ట్ ఆఫ్ ఆల్. ఇక్కడ ఈ పొజిషన్ లో అటాక్ అవుతుంది, హైడ్రోజన్ విల్ అటాక్ అట్ దిస్ పొజిషన్, ఇక్కడ అటాక్ అయింది హైడ్రోజన్. ఓకే, ఆల్రెడీ ద ఎగ్జిస్టింగ్ హైడ్రోజన్ ఇస్ దేర్ and the positive charge is formed in the first step here. Later on, this is రీఅరేంజ్, అప్పుడు ప్లస్ చార్జ్ ఇక్కడికి వస్తుంది. ఓకే, దెన్ ఇది ఎట్లా, ఇది H ప్లస్ అకార్డింగ్ టు మార్కోనికఫ్స్ రూల్. ఓకే, మార్కోనికఫ్స్ రూల్ ప్రకారం వెళ్ళాలి. ఓకే,
లాస్ట్ CH3 వస్తుంది సార్
ఇక్కడ ఓకే, వెరీ గుడ్.
బెంజిన్ దగ్గర బెంజిన్ కటాక్షన్ దగ్గర
సైక్లోహెక్సిన్ లాగా అంతే కదా
సార్.
సైక్లోహెక్సిన్ అండ్ 1 మిథైల్, ఇక్కడ మిథైల్ ఉంటుంది, ఇక్కడ Cl ఉంటుంది. ఎందుకంటే హైడ్రోజన్ ఇక్కడ అటాక్ అవుతుంది, హైడ్రోజన్ విల్ అటాక్ అట్ దిస్ ప్లేస్. ఇక్కడ ప్లస్ చార్జ్ వస్తుంది, ఇది ఇటు షిఫ్ట్ అవుతుంది. షిఫ్ట్ కాగానే ఇక్కడ ప్లస్ చార్జ్ వస్తుంది, అక్కడ మనకు క్లోరిన్ అటాక్ అవుతుంది. ఓకే, దీనికి సింపుల్గా దీనికి ఏం రీఅరేంజ్మెంట్స్ ఉండవు కదా, రీఅరేంజ్మెంట్స్ విల్ నాట్ బి దేర్ హియర్. ఎందుకంటే ఆల్రెడీ ఇక్కడ H2 ఇక్కడ ప్లస్ చార్జ్ వచ్చేసింది కాబట్టి మనకు Cl వస్తుంది ఇక్కడ అంతే. Cl విల్ బి ఫార్మ్. ఇది చెప్పండి, ఇది కరెక్టేనా? ఇది ఇక్కడ వస్తుంది కదా Cl. హలో స్టూడెంట్,
అటాచ్ అయిన దగ్గర వస్తుంది సార్,
ఇక్కడ వస్తుంది కరెక్ట్.
అటాచ్ అయిన దగ్గర Cl వస్తుంది సార్.
Cl వస్తుంది, రైట్. ఓకే, దిస్ ఇస్ అబౌట్ ఎలక్ట్రోఫిలిక్ అడిషన్ రియాక్షన్స్ వి హాడ్ సీన్. ఏమైనా డౌట్స్ ఉంటే ఇంకెక్కడైనా నోట్స్లలో కూడా చూడండి. ఓకే, చూస్తే మనకు ఇంకా కొన్ని కొత్త రియాక్షన్స్ ఉంటే కూడా డిస్కస్ చేద్దాం. ఇవి చాలా అనుకుంటా. చెప్పండి
సార్. ఇది ఇంతకుముందుకి సైక్లోపెంటేనా సైక్లోహెక్సేనా సార్? అది మీరు రింగ్ ఎక్స్పాన్షన్ అయింది
సైక్లోహెక్సేన్, పెంటేన్ నుండి హెక్సేన్ అయింది.
ఓకే సార్, ఓకే సార్.
సార్ కాంప్లీట్ షేర్ చేయరా సార్ గ్రూప్ లో?
పెడతాం. ఇది అర్థమైంది, ఇదే కదా మన.
ఎస్ సార్.
థ్యాంక్ యూ సార్.
ఓకే, అర్థమైందా? ఏమన్నా రియాక్షన్స్ అర్థమైనాయా? చాలా ఇంపార్టెంట్ రియాక్షన్ చూస్తున్నాం మనం. ఓకే, ఏమైనా డౌట్స్ ఉంటే అడగండి. డైబోరేన్ అంటే యాంటీ మార్కోనికఫ్ గుర్తుంచుకోవాలి అంతే. ఓకే, ఇప్పుడు ఇక్కడ మంచి ఎగ్జాంపుల్ ఇది. యాంటీ మార్కోనికఫ్ ప్రొడక్ట్ ఏంటిది? HBr2 అంటే బోరాన్ కనబడంగానే చాలు యాంటీ మార్కోనికఫ్. ఎందుకంటే ఇది బోరాన్ హైడ్రోజన్ కంటే ఎలక్ట్రోనెగటివిటీ తక్కువ. ఓకే, therefore it is going to నెగటివ్ పార్ట్ ఏమో H-, ఇక్కడ Br2 వస్తుంది, ఇక్కడ H వస్తుంది, యాంటీ మార్కోనికఫ్ ప్రొడక్ట్ వస్తుంది. మరి OH రావాలంటే Br2 తీసేసి H2O2 కూడా యాడ్ చేయాలి. ఓకే, హై ఆక్సిమెర్క్యురేషన్, ఆల్ దీస్ వి హాడ్ సీన్. ఓజోనాలిసిస్, చెప్పండి
సార్. H2O2 సమక్షంలో యాంటీ మార్కోనికఫ్ రూల్ జరుగుతుంది సార్.
డైబోరేన్ సమక్షంలో డైబోరేన్ యాంటీ మార్కోనికఫ్ అడిషన్ అయిన తర్వాత ఆ బోరాన్ తీసేయాలంటే మనకి ఇది కావాలి, ఏది? H2O2 కావాలి.
ఓకే సార్.
ఓకే, బోరాన్ ఇక్కడ బోరేషన్ జరుగుతుంది. ఇక్కడ చూడు, ఇక్కడ బోరాన్ ఇక్కడ యాడ్ అయింది, ఇక్కడ హైడ్రోజన్ యాడ్ అయింది. జనరల్ గా మార్కోనికఫ్ ప్రకారం ఇక్కడ బోరాన్ యాడ్ కావాలి కదా, ఇక్కడ హైడ్రోజన్ యాడ్ కావాలి. కానీ ఇది యాంటీ మార్కోనికఫ్ రూట్ లో వస్తుంది అంతే కదా. ఇది అన్సిమెట్రికల్ ఆల్కిన్.
ఓకే సార్, ఓకే సార్, థాంక్యూ సార్.
అంటే దీనికి H2O యాడ్ చేయాలనుకుంటున్నాం. H2O యాడ్ చేసినప్పుడు H2O లో H ప్లస్ OH మైనస్. OH మైనస్ అనేది నెగటివ్ పార్ట్ ఆఫ్ ద అడెండం. మన మార్కోనికఫ్ రూల్ ప్రకారం OH ఇక్కడ యాడ్ కావాలి, ఇక్కడ సెకండరీ ఇది టెర్షరీ కార్బన్ దగ్గర. ఏది డబుల్ బాండ్ వెళ్ళిపోయిన తర్వాత టెర్షరీ కార్బన్ గా మారుతుంది కదా. ఇక్కడ మారితే ఇక్కడ ప్రొడక్ట్ ఏం రావాలి? ఇక్కడ మనకు OH ఇక్కడ ఉండాలి, OH ఇక్కడ ఉండాలి, కానీ ఇక్కడికి వచ్చింది OH అంతే కదా. డైబోరేన్ ఆ స్టెప్స్ తర్వాత తెలుసుకోగానే ఇదైతే యాంటీ మార్కోనికఫ్ ప్రొడక్ట్ వస్తుందని ఆలోచించాలి. ఓకే, థ్యాంక్ యూ స్టూడెంట్స్. షేర్ చేస్తా ఖచ్చితంగా. మీరు ఆలోచించండి ఒకసారి, అన్ని చదవండి, అన్ని చేయండి. ఓకే, థ్యాంక్ యూ.
థ్యాంక్ యూ సార్.
డౌట్స్ ఉంటే కూడా చెప్పండి. థ్యాంక్ యూ వన్ అండ్ ఆల్. బాయ్.
ఓకే సార్, బాయ్ సార్.
బాయ్.
గుడ్ నైట్ సార్.
గుడ్ నైట్. టైం అయిందా?